Hello, everybody. This is a monster lesson that we're going to start. I'm actually going to break it into two pieces. So today is going to be part one of I can graph functions using the table in my graphing calculator. This will be numbers 1 through 8. And then I'm going to make a separate video for the rest. So part one will be numbers 1 through 8. That doesn't mean I'm going to go over all 8 problems, but that will kind of be like the first lesson, and then I'll record a separate one for the one after that. I mean, it starts off real simple. If I want to graph something, I type it into y equals, I use the table, and I plot the points. That's the basic gist of it, but it will build and get more complicated later on. But number one, there's really not much complicated about it. On the grid below, graph the function f of x equals on the domain -1 to 4. So you talked about this back in Algebra 1. A lot of you may be confused on what this is telling you here. When it's telling you the domain, it's telling you that you want to graph it between -1 and 4. All it's saying is when I go to my table, I'm going to copy down the table from -1 to 4. So I'm going to go to y equals, I'm going to do x cubed minus 6x squared plus 9x plus 6. I am going to hit zoom 6 to look at it. So I know it's going to look like that. It's going to be a curve. And I am going to go to my table, and I'm going to write down the points from -1 to 4. So a -1 is -10, 0 is 6, 1 is 10, 2 is 8, 3 is 6, 4 is 10. -1, -10, 0, 6, 1, 10, 2, 8, 3, 6, 4, 10. Now, since it gives you a domain, this means it only wants to see the graph from -1 to 4. So because of that, I am not going to draw arrows. I connect it with curves, and that's 2 points. Okay, that's a very basic graph. This is more like an Algebra 1 question, although this was on the Algebra 2 Regents. If they want you to graph something, type it into y equals, go to your table, plot your points. If it tells you the domain, then those are the points that you're plotting. And if it gives you a domain, you're not going to put arrows. Number 2, it's giving me something to graph. So I'm going to go to y equals, and I'm going to type it in. 400.85 to the power of 2x minus 6. I'm going to start with zoom 6. Zoom 6 did not work out too well for me, and I can kind of cheat here. It's telling me that my x is going from 0 to 10, and it's telling me that my y is going from 0 to 400. So I can just adjust my window according to that. My x is going from 0 to 10. My y is going from 0 to 400. And again, this lesson comes later after some other lessons where I've taught you how to adjust your window already. And we don't even need the picture, but it's helpful to see it. Now, if you just draw that, you're not getting any points. You have to plot the points. So, do I have to plot? How many points do I have to plot? What I would do, being how the graph is going from 0 to 10, I mean, I would probably do 0, 2, 4, 6, 8. You could do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to do every other point. Now, if you notice, there's not really a lot of very nice points here. Who cares? This is algebra 2. Don't expect to see nice points. 0 is 394. 2 is 202.8. 4 is 103. 6 is, I'm just going to call it 51, or 50 point, we'll do 50.9, whatever. Since I rounded that other one to the nearest tenth, we'll round this one to the nearest tenth. 8 is going to be 23.7, and 10 is going to be 9.5. Now, it's giving you the scale. Later on in this lesson, we're going to be finding scale, which is not super complicated, but something that you have to learn how to do. But it's giving you the scale indirectly. So on the x-axis, it's making every other box worth 1. It's telling us that, so I can kind of fill in that that's going to be 2, 3, 4, 5, 6, 7, 8, 9. And now on my y-axis, 1, 2, 3, 4, 5 boxes is 100, which means if I divide 100 by 5, each box is going to be worth 20. Now, do I have to fill in all of them? No. I'll fill in like every other one. 140, 180, 220, 260. So again, each box is worth 20, but I'm just labeling every other box. Just that way, if you label every box, it's going to get really messy. It's going to probably be even more complicated if you do every box. So I think labeling every other box is going to make things a little bit better. Now, understand when you plot your points, they're not going to be perfect. So it's okay. It doesn't have to be super, 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 super accurate. They just need to be between the correct boxes. So 0, 394. 394 is between 380 and 400, closer to 400. 2, 202.8 is going to be a little bit more than 200, so it's going to be somewhere there. 4, 103 is going to be a little bit more than 100. 6, 50.9 is going to be between 40 and 60. 8, 23.7 is a little bit more than 20. And 10, 9.5 is between 0 and 20. It's a curve, so draw a curve connecting those points. You would put an arrow in this direction. You wouldn't put an arrow on the left because your graph is starting at 0. And that's 2 points in the regions. Type it into y equals, go to your table, plot your points, and understand you're not going to get all nice points, so it doesn't have to be super, super 100% accurate. It just needs to be between the two appropriate boxes. All right. Number 3 is kind of annoying. So we're going to go through this one. Normally at this point I'd say try on your own, but we're going to go through it. There's a twist on it. And is there a follow-up question? Yeah, there's a follow-up question as well. So let's go to my calculator. Let's go to y equals. Let's type it in. Alpha window 5 for log base. We learned that earlier this year. X plus 3 minus 5. Zoom 6. Now, it says, this is the tricky part, use an appropriate scale to include both intercepts. So by both intercepts, it's talking the x-intercept and the y-intercept. So I can see my y-intercept, I don't see my x-intercept, so I need to see more of the right. So I'm going to adjust my x max. I'm going to double it as a rule. I always double it when I adjust it. And do I see my x-intercept yet? No. So let's double it again. So I just heard something. And it looks like I see it there now. It's a little bit hard to see, but if I go to my table, again, I'm looking for my x-intercept and my y-intercept. The x-intercept is where y is 0, and the y-intercept is where x is 0. Log base 2x plus 3 minus 5, that's right. So my y-intercept is at negative 3.415. For my x-intercept, I'm looking for where y is 0. And there it is at 29. So my table is going to have to go up to 29. Now, where's it going to start? I'm not going to plot every single point. I'm only going to plot my nice numbers. So let me just go back all the way and see where my nice numbers start from. All these crazy decimals I'm not going to worry about. So negative 2, negative 5 is the first point. Now you see a bunch of errors, and yeah, you should remember with log graphs, the domain is restricted. You can't have the log of a negative number. For untranslated log graphs, it's always 0 to infinity, but this one's translated left 3. That's why the asymptote is at negative 3, and we'll talk about that more in a moment. So negative 2, negative 5, negative 1, negative 4, I see. I see 1, negative 3. I don't see nice points. I see 5, negative 2. I see 13, negative 1. And then 29, 0. Now I have an asymptote at negative 3. So I'm going to want to plot that as well. X equals negative 3 is going to be my asymptote. Now, it says to use an appropriate scale to include both intercepts. Since I've got to plot 29, 0, my scale is not going to go by 1s, but I'm thinking to go by 3s. If I go by 3s, then it becomes 30 instead of 10, and that will fit. So that is what I'm going to do. So I'm going to go by 3s. I'm not going to label every single one. Again, it gets messy when you label them all. But each box is worth 3. Now, since my asymptote was x equals negative 3, then this is going to be negative 3, and there's my asymptote. Negative 2, negative 5. So again, negative 2 is between 0 and negative 3. My y-axis is fine. I can make each box worth 1 on my y-axis. So negative 2, negative 5 is going to be somewhere there. Negative 1, negative 3. Again, negative 1. So negative 2 is closer to negative 3. Negative 1 is closer to 0. The next point is 1, comma negative 3. So 1 is between 0 and negative 3, which I put that in the wrong spot, my mistake. Let's erase that. So negative 1, negative 4 is there. 1, negative 3 is there, between 0 and 3. 5 is close to 6. It's right before 6. So 5, negative 2 is there. 13 is just after 12. Negative 1 is there. It's kind of hard to see. Next to that 12. 29, comma 0. 29 is right before the 30. Again, it's an asymptote, so it's getting closer and closer, but never touching. There's no domain, so it gets arrows in both directions. That's my graph. So there was definitely some twists on this one. The scale was a twist. Finding that 29,0 was a twist. Putting it in between points was a little bit annoying, but that's your graph. Now, describe the behavior of the given function as x approaches -3. So we talked about end behavior. This is kind of a question talking about that. As x approaches -3, the graph, which is y, approaches, since it's pointing down, approaches -infinity. As x approaches +infinity, as we go to the right, well, the graph is pointing up and right, so y approaches +infinity. That's a follow-up question. That doesn't really have too much to do with this lesson here, so I wouldn't be too worried about that right now, but that builds on something we did earlier this year. This was a Regents question, so I just kind of copied and pasted it. So we're dealing with that, so it's not the end of the world if those follow-up questions don't make sense. And in general, this was kind of a tough question. Had some twists, so that's why I wanted to go over it for you. For number 4, what is the solution to the system of equations y equals 3x minus 2 and y equals g of x? So there's two functions. There's g of x, which is given, and there's this one, which is not. So I want to graph both of them. Y equals 3x minus 2 table. Well, there's my picture table. I see that the given graph is from -10 to 10. So I'm going to write down all the nice points from -10 to 10. So I'm not going to do the ones that don't fit. I see -2, -8. I saw -1, -5. 0, -2. 1, 1. 2, 4, 3, 7. 4, 10. Now, you could have also graphed this line, since it's a line, using slope and y-intercept. But, since we've been doing everything in the calculator, I figured it would make sense to stay consistent with that. So, I'm going to plot those points. Again, it doesn't have to be perfect. -2, -8. It's going to be somewhere like that. -1, -5. 0, -2. 1, 1. 2, 4. 3, 7. 4, 10. So, what is the solution to the system of equations? Y equals 3x minus 2 and y equals g of x. Well, one solution is right here, 1, 1. So the only potential option would be choice 4. Now it's kind of hard to see, but it does make sense that they're going to meet, since this is going on forever and this is going on forever. It does make sense that they would meet up at that 6, 16 point. So again, it's a graphing question. Graph it, look at it, and understand that the solution to a system is where the graphs intersect. That's going to come up a lot later on in this lesson. All right, let's take a look at 5. Alex launched a ball into the air. The height of the ball can be represented by the equation h equals. So I'm going to put that into my calculator, but I'm going to put it into the calculator where the h is a y and the t is an x. So I'm going to go to my calculator. Y equals -8x squared plus 40x plus 5. I'm going to start with zoom 6. That's not very good. Now, if I look through the question, though, it's telling me that it wants me to graph from t equals 0 to t equals 5. So I know that my table, my x values, are going to go from 0 to 5. So it's telling me what to graph between. So I'm going to copy down the table from 0 to 5. 0 is 5. 1 is 37. 2, I believe it said, was 53. 3 is 53. 4 is 37. 5 is 5. Now, let's talk about scale. And this is the first time we're doing this. I'm going to put a new page for this. This is very important, especially for the examples later on. For scale, to find the scale, how much you want each box to be worth. The scale must be greater than or equal to the max divided by the number of boxes. The scale can be different for the x and for the y, but to get your ideal scale for the x's and the y's, you're going to take the maximum value and divide it by the number of boxes on the graph. Now, I said greater than or equal to. You need to make a judgment call. You want it to be close to the value. You want it to be a number that's easy to work with. So let's just say I got that my scale was greater than or equal to 4.4. Do I want to make each box worth 4.4? No. It's my graph will look the best at the end, but it's going to be really annoying dealing with 4.4. So I need to choose a value that's bigger than that, that's relatively close, but easy to work with. I would choose 5. It's easy to work with 5. It's not that far away from 4.4. That would be my ideal choice. Now, some of you might say, I want to do 4.5. It's not wrong. It's just 4.5 is going to be a little bit more annoying to work with than 5 would be. So you can make a judgment call at that point. But to start off, to find your scale, you're going to do your max divided by your number of boxes. So let's find the scale. Let's start with the x's. It's going to be greater than or equal to the max divided by the number of boxes. So for the x, the maximum x value is 5. The number of boxes, it's going to be hard for me to count in this little graph here, but I'm just going to tell you that I know that the answer is 20. So now you can go to your calculator and divide them. 5 divided by 20. And again, when I say it's annoying to count, on your paper it's not annoying to count, but on my computer it's not. It's a little annoying to count. I get 0.25. So I want to make each box a value that's greater than or equal to 0.25. The closer it is to 0.25, the better it's going to look, but I want it to be easy to work with. Well, in this case, 0.25 actually is a really nice number to work with. Since 0.25 is a quarter, that means that every 4 boxes would be worth 1, so I'm going to go with 0.25. So I'm going to fill in the graph in a little bit when I have some more space. Space is going to be an issue for this, so I'm going to have to erase some stuff at a certain point. Now I'm going to repeat that process for my y's. The y is, and I'm just going to, again, to save some space, I'm not going to write max over number of boxes. The maximum for the y, well, we're going to say is 53, even though it isn't. We're going to talk about that later. The number of y boxes is also 20. So 53 divided by 20 is 2.65. So I need to choose a number that's close to 2.65, but easy to work with. I'm going to choose 3. So what that means is for the x, each box is going to be worth 0.25. In other words, every 4 boxes is going to be worth 1. For the y's, every box is going to be worth 3. So I'm going to put that somewhere else so I can make the graph bigger so this isn't too confusing. So my x for my scale, my x is going to be 0.25, my y is going to be 3. So now I'm going to make this graph a little bit bigger. And on my x-axis, again, we said every 4 boxes is going to be worth 1. And my y's, every box is going to be worth 3. So I'm not going to label every single box. I'll label every other box, but every box is still worth 3, which makes every other box worth 6. Now I can plot points. 0, 5. Let me just make this bigger so it'll be a little bit easier for me to plot. 5 is just below the 6. 1, 37. 37 is going to be right above the 36. 2, 53 is going to be right below the 54. 3, 53. 4, 37 is right above the 36. 5, 5. Now there's a problem. I don't see a vertex. Parabolas have to have a vertex. I don't see a vertex. So I'm going to have to find that vertex using my graphing calculator. So I'm going to go to y equals, I already have it in here. I'm going to adjust my window based on what I have. My x's are going from 0 to 5. My y's are going from 0 to 60. So that should at least give me a nice picture. I see my vertex. To find the vertex, well, we did that in the previous lesson. Second, trace maximum. I'm going to move my cursor to the left of the point I'm trying to find when it says left bound. I'm going to move my cursor to the right of the point that I'm trying to find when it says right bound. And then I'm going to guess. I'm going to put it where I think it is. And I get, so that 2.49999999 is really close to 2.5. And your calculator rounds weird sometimes. Like my calculator says that. Yours might say like 2.50001. It's 2.5. It's 2.5, 55. So I'm going to add that point in. 2.5 is between 2 and 3. 55 is right above the 54. Since the graph only goes from 0 to 5, I'm not going to draw arrows. So, follow-up question, state the coordinates of the vertex and explain its meaning in the context of the problem. Well, I did that right there. The vertex is 2.5, 55. Now, the fun part that students have is explaining its meaning in the context of the problem. So what's going on in this problem? Alex launched a ball into the air. It's the height of the ball. So who cares about 2.5, 55? What does it mean? Well, x is time and y is height. So the significance of this, I don't know where I'm going to write this. The significance of this, I guess I'll try and write it at the bottom. The maximum height of the ball is 55 feet after 2.5 seconds. When they ask about the vertex, what it means in the context of the problem, make sure you're telling me that it's the maximum or the minimum, whatever it is. The significance of the vertex is that the maximum height of the ball is 55 feet after 2.5 seconds. This is actually an Algebra 1 question. It's a very common Algebra 1 question, but stuff like this comes up in Algebra 2 as well. This is also a stepping stone to what we're going to be doing with the Algebra 2 questions. So scale we talked about for the first time in this example. Scale is very important. You set the to find the scale. The scale is greater than or equal to the maximum value divided by the number of boxes. So I did 5 divided by 20 because 5 was the largest x value, and I did 53 divided by 20 to come up with my scale. I want to choose a number that's close to that number, but easy to work with. Once I had my scale, I labeled my axes, I plotted my points, and then because I saw that the vertex was missing, I had to use the calculator for that. We did that in the previous lesson. And by the way, this lesson is going to build on everything we've been doing, and that gives me my value. Number 6 is pretty much the same type of thing, so I am not going to do that for you. You can do that on your own. You can always refer to the key if you need to. I'm going to go over number 7, and I'm going to start you off on number 8, and then that's what the first part of this video is going to be. John and Sarah are saving money for a car. The total amount of money John will save is given by f of x equals Sarah is g of x equals to the nearest 10th. I'm sorry, to the nearest 10th. After how many weeks will they have the same amount of money? For the same amount, we need to find the intersection. So to find the intersection, I need to graph them both. So I have f of x, I have g of x. Let's go to my calculator. Y equals 60 plus 4x, x squared plus 46. I'm going to go zoom 6. And zoom 6 looks horrible. So if zoom 6 looks horrible, I go to zoom 0, which is zoom fit. And that looks better. I see the intersection. However, understand that because we're talking about a real life situation, I can't have negatives. So since I can't have negatives, I really don't care about that point on the left. In fact, I'll adjust my window accordingly. I'm going to make my x min and my y min 0. Again, because it's a real life situation, I wouldn't have any negatives. Does this look good? Yes. So, because my window is going from 0 to 10, I'm going to graph them from 0 to 10. So when I go to my window, I'm sorry, my table, I've got 060 and 046. I don't need to write down every single point. However, I'm definitely looking for my point of intersection, so if I see my point of intersection, I definitely want to include that. I'll do 2, 68, and 50. No, I want to include the 1 just because I see that 1 is the vertex. So I'm going to include 1 as well. So I'm just going to erase that. Any key points on the graph you want to include, and I see that in my Y2, I see my mirror, and I see that 46 in the middle of it. So I do want to include that. So 1 is going to be 64, and then 47. 2 is going to be 68 and 50. 4 is going to be 76 and 62. 6 is 84 and 82. 8 8 is 92 and 110. And 10 is 100 and 146. Now I don't see the intersection in the table, which means I'm going to have to use my calculator to find that. We'll do that afterwards. Now, scale for the x's. Again, for scale, it's greater than or equal to the max divided by the number of boxes. So in this case, the maximum x value is 10. The number of boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, I think it's 29. I hope it's 29. It's just very hard for me to count on this little screen here. It shouldn't be as hard for you. Let's see if we can do this. That's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30 boxes. So that's going to be 0.3, it's 1/3, which is nice to work with. If every box is 1/3, then every 3 boxes is going to be worth 1. So that whole dashes thing I just did is kind of in the way now. Every 3rd box is going to be worth 1. Now for the y's. The maximum y value I see is 146. The number of boxes, 2, 4, 6, 8, 10, 12, 14, 16, 17. 146 divided by 17 is 8.58. Now, 8.58 is not fun to work with, so I want to pick a value that's bigger than it, relatively close, but easy to work with. I think it's a no-brainer. I'm going to go with 10. So, my scale, my x's are going to be 1/3. My y's are going to be 10. So I'm going to erase that now so I have some space to work. And let's put those values in. So 1, 2, 3, 4. I already kind of set up my x's. 7, 8, 9, 10. My y's are going by 10, but I will label every other box, or else it gets very messy. Or else it gets, hold on one moment. Okay, so I'm going by 10s, but I'm labeling every other box. That's 100. That's 120, 140, 160. Now I'm going to graph them. These are long videos. Yikes. 0, 60, 1, 64. 64 is between 60 and 70, but closer to 60. 2, 68 is closer to 70. 4, 76 is a little bit less than 80. 6, 84 is a little bit more than 80. 8, 92 is a little bit less than 100. And the last point there was 10, 100. And you draw the line. Now I'm going to use a different color for the other graph. 0, 46 is a little bit more than 40. 1, 47 is just a little bit more than that. 2, 50. That's my first like nice point. It's actually, where it's supposed to be. Through 4, 62. 6, 82 is a little bit more than the 80. 8, 110 is a little bit more than the 100. I'm sorry, it's actually right there at 110. And finally, 10, 146 is a little bit more than the 140. This one's a curve. It's going to look something like that. So this is g of x, and the blue was f of x. Now, again, I'm looking for the intersection point. The nearest 10th, well, it's somewhere here, but I really can't tell exactly what it is. So I'm going to have to go to my calculator, second trace, and find the intersection. So I go to the point, I hit enter, enter, enter. So to the nearest 10th, I'm looking at 6.2, 85.0. To the nearest 10th of a week, after how many weeks X will they have the same amount of money saved? So it's asking for X. So the answer would be 6.2 weeks. Explain how you arrived at your answer. The intersection point is 6.2, 85.0. That's what I would say. We're looking for the intersection point. Again, another long question. Number 8 is kind of long as well. However, I'm just going to give you a little bit of a hint, and I'm going to have you try it on your own. Well, I'm not just going to give you a hint. I'm just going to get you started on it. It's giving you an equation. So listen, if they want us to graph an equation, we just type it into the calculator and we graph it. Negative alpha y equals enter. 1 over 225 x squared plus alpha y equals enter 2/3 x. It's telling me it wants me to graph it from 0 to 250. Or from 0 to 150. I don't know if I just said 250. So I know that my table is going to go from 0 to 150. Am I going to plot all those points? No. I'm only going to plot the nice points from 0 to 150. So when I go to my table, 0, 0 is a nice point. So I'm going to write that. That's not a nice point. That's not a nice point. I see all these fractions there. I don't want those. I don't want those. I don't want those. 15 looks good. 15, 9. I'm going to plot. Nope. 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 30, 16. And you're going to kind of build your table from there up until you get to 150. So 150 should be at the bottom of your table. Now you're going to have to create your scale. Again, your scale is going to be great for your scale. Your x is going to be greater than or equal to the max divided by the number of boxes. and your y is going to be greater than or equal to your max divided by the number of boxes. So once you get your table, I mean, for the x's, it's going to definitely be 150. For the y's, whatever your largest value in your table is, that's going to be your max. Find your scale, set up your axes just like we did in the previous questions, plot the points, draw your graph. Answer the follow-up questions. It's not too bad, but you just need to kind of go through it and obviously build on everything else we did. So obviously this lesson is going to take a long time. I told you I was chopping this into 2 pieces. This is only the first piece of it, and it was a very long lesson. So we're going to be spending a lot of time in it. But at this point, you need to kind of go through the examples we didn't do, including number 8, struggle through it a little bit, refer to the keys if you need to, and go from there. I can graph functions using the table and the calculator. And I'd say if there's one other important thing to take from this, in addition to the fact that we're building on previous lessons by finding, the intersections and the maximums and the minimums, is that for scale, the scale is greater than or equal to the max divided by the number of boxes. Have a great day.